Alright, so today's lesson we're going to talk about domain and range and even and odd functions. So, the graph of function is the graph of its ordered pairs. Again, this says x, y, or f of x. F of x means y, same thing, right? Domain is a set of all first coordinates of the ordered pairs, aka the x values, range is the y values. But here's the thing. When you're looking at a graph, domain is going to be left to right. And range is going to be from bottom to top. So the way I think about this is if I had a graph that looked like this right here. Okay, those arrows, you have to imagine that the lines go on forever. So my domain is how far left would this graph go? Well, if I follow the arrow, it's going to go on forever, so it's going to go to negative infinity. How far right would the graph go? Well, that would go to positive infinity. All right, so my domain technically would be negative infinity to positive infinity. Bottom to top, the bottom of the graph is at 0. The top of the graph, if I keep going up, it goes to positive infinity. So my range is from 0 to infinity. And I used a bracket on 0 because the line touches 0. So that means there's a point there, there's a coordinate there, aka a closed circle, which is a bracket. All right, so we're going to do a bunch of examples of these. So determine the domain and range of each function from its graph. Write your answers in both interval notation and set builder notation. We're really just going to focus on interval notation. Okay, so this graph right here, domain is how far left to how far right, and you have to remember that order. So how far left, it goes to negative infinity because it's going to go on forever, all the way to positive infinity. That's how far right it's going to go. Your range is how far down, so bottom to top. So it goes to negative infinity as well, and positive infinity up. Linear functions, guys, are going to have domain and range of negative infinity and positive infinity. We did an example just like this, however, it's a little different on number 2. Your domain would be negative infinity to positive infinity because it goes forever in the left, forever in the right. And your range is bottom to top, so it's going to be negative infinity because it's going down forever all the way up to 1, 2, 3, 4. There's a closed circle there, so I put a bracket. So negative infinity to 4. All right. Function C, how far left does it go? Well, it goes to negative 1. How far right? To 3. I put brackets because they're closed circles. Your range is going to be 1 to 2 because it goes bottom of this graph would be 1, top of this graph would be 2. Now this one would be, hey, another question that goes with this is this function or is this graph a function? Well, the answer is no, because if I draw a vertical line, it's going to hit it twice, right? So now it says give 2 coordinates that prove it wrong. Well, here's 2 right here. 3, 0, and 3, 1. And if you think about it, the x repeats, so it can't be a function, right? All right, rational expressions I think are the hardest when it comes to domain and range. The domain on this one, negative infinity to my left, but as I work in, you notice there's a gap here, right? So we have to have a union. So 1, 2, 3, 1, 2, 3. It's at negative 3. So I would say union, negative 3 to infinity. Same way with my range. Bottom, it's going from negative infinity all the way up, and then you get to 0 and it stops. So then I got to say 0 to infinity. Because if you're looking at this, right, it's going to stop at 0, and then it's going to pick back up at 0, but we don't include it because there's a dotted line there. So that one's probably the toughest one for domain and range. These ones says determine the domain and range of each graph. What I did is I graphed them on Desmos, okay, and I encourage you guys to do the same. I just want you to try it by yourself and see if you can figure out the domain and range. So if you look at it on Desmos, that's the red one. So notice how far left it goes. It goes to negative 6 all the way to infinity. So that should be your domain. Your range is going to be from 2 to infinity. All right. Function B, if I graph that one, looks something like this. Notice it stops at 5 and 0 just like the other one. So this one's going to be, well, kind of like the other one. The other one stops at different numbers, but the same idea. So my domain's going to stop at 5. So I'm going to say negative infinity to 5, union 5 to infinity. And vice versa, my range is going to be negative infinity to 0, union 0 to infinity. All right, so I would just graph those on Desmos and see if you can compare them and get the right answers. Even and odd functions, so there's two ways to do this. You can do this numerically, or you can just look at the function and kind of go, I'll give you some hints to go with it. So when you're doing this, in order to determine whether it's even or odd, there's two ways. The way that I think about it is if the only thing that's got an x, so you're looking for all the x's, as long as it has an even exponent, it's going to be an even function. Or anytime you plug in f of negative x, so 1 plus 1 over negative x squared, well, if you do that, you get x squared. Do you see how that's the same thing as what you started with? That means it's going to be an even function. Now, odd, you can look at all the exponents. That's a 1 there, right? We just don't write it. If they're all odd numbers, it's going to be an odd function. Or, again, you can plug in negative x. Now, look at this one. This one's a little bit different. When I plug in negative x, notice the signs change. So if all the signs change, it's going to be a odd function. All right. Lastly, it could be neither. So if I have an even and an odd exponent, that's probably a good hint that it's going to be neither. But again, I could plug in f of negative x. Now this one, if you notice, one sign changed and one didn't. That's a combination, so it's going to be a neither. All right. Lastly, you're going to have something like this. I just want to throw this in there because it shows up on the Hawks. We're at the relation y in terms of x. Again, you're just solving for y, so I'm going to subtract y. So I'm going to have 2x squared minus 4x equals 4y, and I'm going to divide everything by 4. So when I do that, I get 2x squared minus 4x over 4. 2 goes into all of those, so I'm going to divide them all by 2 and rewrite it like that. So now it's going to have you graph the relation. Is the relation a function? Justify using. To graph it, just plug in 1 for 0, or 1 for x and 0 for x, and solve it and graph those 2 points. So when I plug in 1, I get 1 minus 2 over 2, which is negative 1/2. So 1 negative 1/2 is going to be right here. Plug in 0, I'm going to get 0 over 2, which is 0, so 0, 0. All right. Again, you can go type this in on Desmos and get 2 points. I'm just going to keep plugging in points, and you would graph it. I'm not going to complete this one because, again, it's something you do on Hawk, so I don't want to show you completely what it is. So now it says use your answer in part A to evaluate the function at x equals negative 3. Well, all you're going to do is plug in negative 3. You're going to rewrite the equation that you had, that we rewrote. I'm going to plug in negative 3 for x, and I'm going to solve it. So when I do that, I get 9 plus 6 over 2, which is 15 over 2, and that would be your answer. And it says determine the domain and range, right? Again, you would graph it on Desmos and look at how far left, how far right, bottom to top. All right. If you have any questions, your homework's going to be 3.1 certified, I believe, but just let me double check that. Double check the announcement, make sure it's correct. Otherwise, have a good day.